morning, students. So yesterday in the structure of atom chapter, we had discussed about the postulates of Bohr's atomic model. And in today's video, we are going to study about the merits of Bohr's model as well as the limitations of the Bohr's model. So in today's video, there will be lot of formulas and their derivations that you have to understand. So it is better that you sit with your registers and with your pen. So as I'm going to explain you after understanding the video, you do it in your registers and try to understand those formulas and derivatives, because they are also going to be used in different calculations. Clear? So let us move ahead with the merits of the Bohr's model. So what were certain merits of Bohr's model? Firstly, Bohr's model was able to explain the stability of an atom. So first point, explain the stability of an atom. If you remember, Rutherford was not able to explain the stability of an atom, right? But according to Bohr's model, he was able to explain the stability of an atom. All that I'll explain it to you just now in detail. First, let me write down the different merits. The second was, through Bohr's model, we are able to calculate the radius of a particular orbit. So, radius of a particular orbit can be calculated. Third merit of Bohr's model is what? We can also calculate the energy of an electron which is placed in a particular orbit. So third point is to calculate the energy of an electron in a particular orbit. Okay, and the fourth merit of Bohr's model was that it was able to explain the atomic spectrum of hydrogen. So explanation of the atomic spectrum of hydrogen was also clarified by the Bohr's atomic model. So these were some of the merits. First we will understand the merits and then we will move to the limitations of the Bohr's model. So firstly, coming to the stability of an atom. Now, with the stability of an atom, what do we understand? If you remember, in the Rutherford's model, what did Rutherford explain? That the atom, it continuously moved in the circular form. It was losing its energy, and a time came when it collided with the nucleus. So if an electron collides with the nucleus, means what? Matter cannot exist, and therefore Rutherford's model was discarded. So Bohr gave his theory, his postulates, in which he tried to explain that the atom shows stability. So how? What did he say? So according to Bohr's theory, an electron, it neither gains or loses energy while it is moving in a particular shell. Why so? Because each shell has certain energy. Therefore, in the postulate I had explained you that each energy shell is called as stationary orbit or energy shell, because each of them has a specific energy level. So this implies what? That if an atom is not disturbed, then the electron will go on moving in that specified orbit forever, and the atom hence will not collide with the nucleus, and this can explain the stability of an atom. I hope the first point is very clear to you about the stability of an atom. I repeat, understand this point. As per Rutherford's model, if you remember, it was not able to explain the stability of an atom. Why? Because while the electron was continuously moving in a circular motion, a time came while it was losing its energy, it collided with the nucleus. So here Bohr explained that every orbit had a definite energy, or it is called as a stationary orbit. Why? Because it has a definite energy level, and hence according to this, the electron, when it is revolving in its orbit, it neither loses or gains energy while it is in that particular shell. And this also explains that if an atom is not disturbed, it that particular electron will go on moving in that specified orbit forever, and hence the atom will remain stable as it will not collide with the nucleus. This explains the stability of an atom. Now next we come to the second point, that is the how to calculate the radius of a particular orbit. Okay, so to understand this, firstly you need to remember the formula. That is very important. So according to the postulate of Bohr's theory, what did it explain? It explained us the how we can calculate the through the postulates of Bohr's model. It is very easy to calculate the radius of any particular orbit. So the formula that you have to learn for this is Rn is equal to 4 pi absolute naught, okay, n square h square upon 4 pi square m e square, where this I hope you are trying to understand, this is n, okay, where h square, this is the Planck's constant. H is your Planck's constant, right? When you substitute the values over here, then you get a formula where Rn will be equal to 52.9 n square upon z pm. Okay, so z is the atomic number and n is the number of shell. Okay, so this is what we need to remember, and this is the formula that we need to learn. Right, now how do we get this formula and how do we get this value is what I'm going to explain you in detail. So try to understand, though that all that is not necessary to be learned. This is what you have to learn, this is what you have to use in your calculations, in your numericals. But how do we get all this? Straight away if I give it to you, you will not be able to understand. You will be wondering, miss, how did we calculate this radius? So this is the explanation that I am going to give you about how to get this formula, and from this formula how did we get this value, and how to calculate the radius of any particular orbit. Okay, I hope this is very clear to you. So let us move ahead to understand this formula. First, let me draw a figure for you and then I will explain you further. Okay, so let this be a shell. This is your nucleus. I'll explain everything just now. Try to understand this figure. Force of attraction. Okay, so now understand this figure first. Now considering an electron of mass m, okay, and a charge E over it, which is revolving around the nucleus, right? Nucleus of charge what? Ze. This is what? Ze is the charge of the nucleus. Is this point clear? Where what you see Z is the atomic number. Now what is this V? It is the tangential velocity of this revolving electron, okay, and this R is the radius of the orbit, right? Now there is electrostatic force of attraction between this electron and this nucleus, fine, between this nucleus and the electron, right? And over here this is the centrifugal force, right, which is always equal to the force of attraction, and it is always opposite to the force of attraction. So force of attraction is over here, so this is opposite to it, and what is the formula written for it? mv square upon r. Is this point very clear to you? Now the electrostatic force of attraction between this nucleus and the electron, if we apply the Coulomb's law, it will be equal to, I'll write it over here, it will be equal to it is directly proportional to Ze, because this electron is in the nucleus, so it will be positive with the electron multiplied, sorry, I'll put over here, multiplied with the electron which is negatively charged upon r square, upon the distance square, right? So when we, this is directly proportional, okay, when we remove the directly proportional, then we have to put a constant. So how are we going to then write this? Then to put a constant, we write over here k. So how do we write then? Kz, E plus into E minus. Now E plus and minus doesn't make, plus and minus doesn't make any difference. So we can write what? E squared upon R square. I hope this formula is very clear to you. What is this? The electrostatic force of attraction between the nucleus and the electron. This is what I have found out over here. And what did I tell you? Where this K is the constant, okay, and this K is the constant which is always equal to 1 upon, do remember this, which will be used every now and then, 1 upon 4 pi absolute naught, right, where this is called as what did I say? Absolute naught, or it is the absolute permittivity of the medium. Okay, I am writing it down over here. This is also called as absolute permittivity of the medium. Clear? And it has a numerical value. What is the numerical value of this? It is always 9 into 10 to the power 9 Newton per meter, Newton meter per Coulomb square. Okay, this is the value of this constant K. Now, as I told you, force of attraction is always equal to the centrifugal force. Okay, I'm writing it down over here. I'm writing everything. Note it down in your registers to make yourself understand. Force of attraction is always equal to what? Centrifugal force. Clear? Now, what is force of attraction that I had told you? This is the force of attraction, right? So, KZE square upon R square is equal to centrifugal force. What was the centrifugal force that I told you? mv square upon r, right? So now let us find out what is the velocity square. So velocity square will be equal to what? Kze square upon m. Did you get that? KZE square upon m, and this r will be cancelled with this r. Okay, so this will be cancelled with this, so m r will be written over here. Right, now according to the one of the postulates, if you remember the third postulate that I had told you, that angular momentum is equal to what? This is equal to mvr, which was equal to nh upon 2 pi, where h is your Planck's constant. What is h? H is your Planck's constant, and it always has a set value, which I am going to explain you just now. So should I rub this off, because I need more space to explain you. So angular momentum is equal to mvr, which is equal to nh upon 2 pi, and I told you what is h. H is your Planck's constant, which also has a set formula. So what will be v over here now? V will be equal to nh upon 2 pi mr. Okay, now we put the value of this v in the first equation, that is over here. This is your first equation and this is your second equation. We place this value over here. So putting the value over here, what do we get? I'm writing it down over here. Okay, so n square h square upon 4 pi square m square r square is equal to k z e square upon m r. Is this clear to all of you? What did I put over here? This value I have placed over here. So this is v square. So what did I write here? This whole has to become whole square. So I wrote n square h square 4 pi square m square r square. This should be equal to kze square mr. I hope till here everything is very clear. Now m and m gets cancelled, r and r gets cancelled. Is anything else going to get cancelled? No. Okay, so let's go ahead. Thus what do we get? N square h square upon 4 pi square mr is equal to the constant z e square. Okay, now how to find out the radius? So radius will be equal to n square h square upon 4 pi square m k z e square. So this is what I had given you in the formula earlier, which I had written over here, if you remember. Okay, this was the formula of the radius of any particular orbit. Now over there I had written what? 1 upon 4 pi absolute naught, right? Do you remember that? So this is what it is equal to k. So k is over here. So what was the formula that I had written earlier? The formula that I had written earlier was Rn is equal to 4 pi absolute naught. This is what I had written. N square h square upon 4 pi square m e square. Okay, this was the formula that I had written earlier. Now let's correlate it. N square h square, right? K is what? 1 upon 4 pi absolute naught. So this is the reciprocal. So this will go on top. So over here I have written, then 4 pi square m. I forgot to write z over here. Okay, z m e square. So this was the formula that I had given you. I hope till here everything is very clear. Now I'm going to place the values and get the formula that I had given you. What was that? that was 52.9 n square upon z. That was the formula that I gave you. So let us put all the values now of the r. So I am placing it over here. Now the radius of an atom of an hydrogen, radius of an atom of hydrogen, what formula are we going to take? Rn is equal to 4 pi absolute naught n square h square upon 4 pi square m e square. This is the formula that is given to you. Now why I did not write z? Because z is always equal to 1. The atomic number of hydrogen is 1. So that is, if we remove hydrogen, 1 has no meaning. So this is the formula that we get. Now we substitute all the values over here. So let us begin. I'm using this formula, okay? So R is equal to n square into h. H, as I told you, it is Planck's constant, and the value of Planck's constant is 6.625 into 10 to the power minus 34. All this constant value will be given to you in the question, so you don't have to learn that, and if you learn it, then it's very good. To the power of 2, to the power of 2 upon 4 into, what is this? Pi. What is the value of pi? 3.14 square into the mass. What is the mass of the electron? Mass of electron is 9.1 into 10 to the power minus 31. This is 31. Okay, into what is the value of z? Z, as you all know, it is 9 into 10 to the power 9 into e square. E square is what? The electron. What is the charge of electron? 1.6 into 10 to the power of minus 19, and this is whole square. This is whole square. So if you calculate the whole thing, what are we going to get? We will get 0.529 into n square into 10 to the power minus 10 n. Okay, so in total this is equal to 0.529 into n square Armstrong. This is what I had given you. Okay, now let us do certain calculations. Okay, thus to find the radius of first orbit, what formula are we going to use here? 0.529 into 10 to the power minus 8, or if we are using 10 to the power minus 8, then it will be centimeter. Okay, then it is given in centimeters, and if we are using to the power of minus 10, then we are calculating it in meters, and if we are not using only 0.529, then we are giving the unit in Armstrong. I hope that is very clear. So over here, just to give you another point to understand, if it is 10 to the minus 10, then the unit has to be in meters. If there is no 10 to the power of anything, then it is Armstrong. Then if it is minus 8, then it has to be in centimeters. So all the three possible units I am trying to explain you over here. So this becomes 0.529 into 10 to the power 8, and what did I tell you? Radius of the first orbit. So over here your n is 1, so into 1 square. So what will be the radius of the first orbit? It is always 0.529 into 10 to the power minus 8 centimeters, or 0.529 into 10 to the power minus 10 meters or 0.529 Armstrong. I hope this point is very clear. Now let us see the radius of the second orbit. I hope you are trying to follow this. So over here this will be equal to 0.529 into 10 to the power minus 8 into 2 to the power of 2. 2 2s are 4. Multiply the whole thing. What do you get? 2.11 into 10 to the power minus 8 centimeters. Okay. So this comes in centimeters. If I have to show it in meters, then what will be my value? It will be 2.11 into 10 to the power minus 10 meters. And if it has to be in Armstrong, then what it will be? 2.11 Armstrong. So this is how the radius of the orbit can be calculated by the Bohr's atomic theory. I hope this is very clear. How did we get this also is very clear. Do all that calculation in your register. You will definitely understand. If you don't understand, do it twice and thrice. And still if you don't understand, then you definitely ask me. Now we move to the third merit of Bohr's model. Now what was the third merit? It was to calculate the energy of the electron in a particular orbit. Okay, you are not able to see because my table is still wet and my pen is not working on the wet table. Particular orbit. Okay. So once again, I'm going to give you the formula, I'm going to give you the value, and then I'm also going to explain you how did we get that formula. So to find out the energy of electron in a particular orbit, energy of an electron in a particular orbit, this is always equal to minus 1 upon 4 pi absolute naught whole square into 2 pi square m e to the power of 4 upon n square h square. Okay, over here try to understand En is what? Energy of the electron in any of the particular orbit in the nth energy level. Okay, then as I told you, what is this? This is the permittivity of the free space or in the air or in any medium. Then what is m? M is the mass of the electron. What is E? E is the charge of the electron. And what is H? H is the Planck's constant. What is N? N is the number of orbit found. Everything is very clear. Now, as you know, what is the value of 4 pi absolute naught? It is always equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, and when we substitute all the values, what do we get for En? It is always equal to minus, because there is minus over here. So minus 1312 upon n square kilojoules per mole. This is the value. So formula that you have to learn to calculate the energy of electron in a particular orbit will be this, and this will be the final value that you have to learn. And now whichever orbit it is going to ask, you will put that value over here of that particular orbit and calculate the energy of the electron in the particular orbit. This is what you have to learn. Now once again, how did we get this formula? Many of you will not be able to understand. Miss has just given the formula and finished off. I don't want to take any shortcuts, so would like to explain you, but this is only what you have to learn. What now explanation that I'm going to give you, the derivation that you don't have to learn, but you have to understand to learn this point. I hope this is very clear to you. So let us begin to understand how did we get this formula. Clear? Let us consider that the total energy of the electron is always E, the capital E, and the sum of the kinetic energy and potential energy is always equal to E. So what do I write? E is equal to sum of the kinetic energy and potential energy. Okay, I won't go much in detail, but what is necessary is what you need to understand over here. Right? Now, kinetic energy, it is due to the now, kinetic energy, it is due to the movement of the electron in the circular path. Okay, and potential energy, it is due to the force of attraction between the proton which is present in the nucleus and the electron. I hope this is very clear. Again, I am repeating it over here. If this is a nucleus and this is your stationary orbit and this is your electron, then kinetic energy, what is this kinetic energy? It is due to the movement of this electron in the circular path. Okay, and how do we get the potential energy? It is due to the force of attraction between the protons and the electrons. Is this point clear? Thus, what is kinetic energy? Kinetic energy is equal to half mv square. I hope you all know this, right? Now, what is potential energy? We should always know that potential energy, it is always given in uh, minus. Why is it given in minus? Because the charges, they are opposite, and whenever the charges are opposite and they attract, then the value will always be given in negative. I hope that's very clear. So potential energy, what did I say? The force of attraction is over here, opposite charges are there, attraction is there, therefore the value will always be in negative, and therefore potential energy will be equal to Z E square upon R. Do you remember? Z E positive for the proton over here and E for the electron. So plus and minus has no value over here. So what do we write? Z E square upon R. And since this is directly inversely proportional to the radius and directly proportional to the atomic number, right? But when we remove the proportionality sign, then what we have to write? K over here, right? So this becomes your potential energy, right? Now, there are two types of forces that takes place over here. One is the centripetal force and the other one is the centrifugal force. What is centripetal force? It is always towards the nucleus. Centripetal force is always towards the nucleus and centrifugal force is always away from the nucleus. And we can also say that they are simply attractive or repulsive forces, right? So what do we know? That both these forces, they are equal. So what do we write? E is equal to K Z E square upon 2R minus K Z E square upon, this is E square, okay? E square upon R. This is equal to what? K Z E square upon 2R. Okay? What have I done over here? I have put the value of mv square from equation 1 which I wrote in the for calculation of the radius, if you check that. Okay, so over here now putting the value of r, how? E is equal to kz E square upon 2 into 4 pi square m k z E square upon n square h square. This and this also gets cancelled over here. Then this becomes what? 2 pi square z k square then m e4 upon n square h square. Check. 2 pi square z should be square z square k square m e to the power of 4 upon n square h square. Okay, now in only z square and n square, these are the variables. Rest are all constants. You know the value of pi, you know the value of k, we know the mass of the electron, we know the charge of the electron, we know the Planck's constant. We only don't know what is z square and what is z and what is n. Clear? Therefore, I said that z and n are the only two variables. Rest are all the constants. So now for hydrogen atom, we know z is equal to 1. Z is equal to 1. So what will be the energy then? It will be equal to minus. Okay, I forgot to write over here minus, isn't it? This was minus over here. So minus 2 pi square. Now z is 1. So 1 square has no meaning. Then k square me4 upon n square h square. Okay. Now when we put all the values, right? Let us put all the values. So E is equal to minus 2 into 3.14 whole square into what is the value of k? 9 into 10 to the power of 9 ka whole square into what is the mass? 9.1 into 10 to the power minus 31 into what is E? 1.6 into 10 to the power minus 19. How much? The power of 4 whole upon, sorry, n square. Now n square we don't know, that is a variable that we need to find out. Okay, that will be given in the question. Upon what is h? Planck's constant 6.625 into 10 to the power minus 34 ka whole square. So all this when you are going to calculate, it is going to come out to be 21.79 into 10 to the power minus 19 upon n square joule per atom. Okay, this will be equal to somewhat minus, did I write here minus? No, minus 13.6 upon n square electron volt per atom. Okay, because 1 joule somewhat is equal to 6.241 into 10 to the power 18 electron volt. All this calculation won't be asked, but this is how you get this value over here. Over here, if 1 joule is equal to 6.2419 into 10 to the power of 18 electron volts, then this value becomes minus 13 no, it becomes this, it becomes 1312 upon n square kilojoules per mole. Okay, so this is the value that you have to learn. This is what I have given you over here. Okay, now let us understand one example. Suppose we have to substitute the value of N as 1. So what will be your answer? 1312 kilojoules per mole is the energy of the electron when it is in the first orbit. I hope that is very clear to you. If it goes to the second orbit, then 2 into 2, 4. So 1312 upon 4, that you will calculate. That will be the energy of the electron in that particular orbit. Fine. I hope you are trying to understand this point. If N is equal to 3, then 1312 upon 9, because 3 3s are 9. So when you get to do the answer, minus 1312 upon 9, this is going to give you the energy of the electron in the third orbit, and so on. This is how we calculate the energy of the electron in a particular orbit. So actually you have to learn these two form. This is the formula and this is the actual formula that you need to know for doing the calculation work. Is that very clear to all of you? So, but how did we get this is the whole explanation given to you over here. What did I say? That the sum total energy of the electron is always equal to kinetic energy and potential energy. How do we get the kinetic energy? It is always due to the movement of the electron in the circular path, and potential energy, it is always due to the attraction between the proton and the electron. Right? Now, two types of always forces act between the nucleus and the electron. What are they? The centrifugal force and the centripetal force. So as I told you, the centripetal force always is the force which is towards the nucleus, right? And the centrifugal force is always away from the nucleus. Thus we can say that both they are opposite, and we can say that these are also the attractive and the repulsive forces, and they are always equal. They are always equal, and hence only the electron stays in the concerned orbit or in a particular orbit. So after putting all that together, we calculate all this. Then when hydrogen becomes 1, then this is the formula that we get. Putting all the values, we get 1312 upon n square kilojoules per mole. So this is what we need to learn. I think the video has become too long. So explanation of the atomic spectrum of hydrogen and the limitations, I will come back to you in the next period. Okay, in the next video. Till then, thank you.